Hey guys, this is our third day, I think, of electrochemistry. We're going to talk about how to identify if things are oxidized or reduced, and then we're going to talk about how to balance half reactions. This is the third time I've tried to record this video because my internet kept going out. So if it happens again, you might have more than one video to watch. I don't know. I might also lose my mind if it happens again. One more thing, I wanted to talk about the homework. You guys have been doing a great job with the homework. I looked at the scores and they were very high. And this is a kind of tricky unit, so that's good. But some of you have emailed me and you're concerned about formatting issues. So I just want to assure you that I go through the assignments and just double check, did things get graded correctly? Especially for things where you're writing an answer in. So like if you wrote the word 5, but I put the number 5, you will obviously get credit for that. So I don't want you to worry about that. If you feel like I didn't go back and grade it properly or accurately after it's in school tool, please let me know. But I'm doing my best to go through and mark everything as it should be. Okay. So let's get started. Oh, excuse me. All right, so at the end of the video yesterday, I talked about what the terms oxidation and reduction mean. Oh, I'm gonna get rid of my face, hold on. There we go. Okay, so I talked about what the terms oxidation and reduction mean. So I used the little trick, Leo the lion goes grr, where Leo stands for a loss of electrons is oxidation, and grr is gain of electrons is reduction. So that's fine to know the definition, but it's not going to super help us when we're trying to identify. When you're trying to identify things, you want to look at their charges as they go from left to right. So let's talk about reduction first. It's easier to understand. Since you're gaining negative numbers, since you're gaining electrons, which are negative, the charge goes down. And for oxidation, since you're losing negative numbers, the charge goes up. So that's what we're going to really be focusing on today. Okay, so for this section, I'll do number 1 with you, and then I want you to pause the video and try to do the rest on your own. So if we're looking at the left side, we have magnesium. It's not combined with anything. I'm also going to ignore any numbers, any coefficients, okay? So since this is a free element, that was the first thing we learned about our day 1 of this unit. Free elements have an oxidation state of 0. Oxygen is also a free element, so its oxidation state is 0. And then when it's combined in a compound, that's when you need to go into your periodic table and look which one of these has more than one possible charge. So it turns out that magnesium is always +2. And remember, when you add your charges together, they need to equal out to 0. So to get me to 0, I'm going to need -2 here. Okay, so can you guys please push pause and try to do the rest of these? And then when you come back, I'll go over them. All right, so in number 2, we have a free element, 0. Another free element, 0. Ignore coefficients. Okay, so in this one you have N and H. So if you look at H, it says it can be +1 or -1. H is only -1 when it's combined with a metal. So H is going to be +1 because nitrogen is a nonmetal. I multiply by 3, and I get +3. I know that this has to equal 0. So my nitrogen needs to be -3. Okay, on the next one, ignoring coefficients. Hg and O, Hg can have different charges, so I look at O. O is -2, Hg is +2 to get me to 0. These two guys are free elements, so they'll be 0 and 0. All right, next one, ignore. H2 and O2 are free elements because they're not combined with anything else. So 0 and 0. On this one, oxygen is -2. If you multiply times 1, you get -2. To get to 0, this would have to be +2. But see how I have 2 hydrogens here? I want to divide 2 divided by 2 for a +1 charge. Okay, and then the last one we're going to do pink. Magnesium is free element, so it's 0. Ignore. Okay, so for this one, I'm going to do the N last. So if I look up silver, my charge is +1. Multiply it by 1, I get +1. Oxygen, -2. Multiply by 3, and I get -6. I have to equal 0 at this point. So we're missing N, +1, -6. I would need a +5. Okay, which also I'm going to put up here because there's only one of these. All right, so on this side, same idea. Magnesium is +2. I only have 1, so it's +2. Oxygen is -2. And this time I have 6 because I multiplied those together. So -2 times 6 is -12. And now to get me to 0, I have +2 and -12. So this has to be +10. So you should notice that the 2 outside parentheses needs to be distributed inside as well. So I'm going to do 10 divided by 2, and I'm going to get a +5 up here. And then silver is 0 because it's by itself. Okay, so now what I'm going to do is go through and decide who gets oxidized and who gets reduced. I'm only trying to get these purple guys. There we go. Okay, so to decide who gets reduced, you want to look for whose charge went down. To decide who gets oxidized, you looked for whose charge went up. It's about where my video cut out last time, so I'm getting nervous. All right, so looking left to right, magnesium went from 0 to +2. So its charge went up, so magnesium gets oxidized. I'm going to write magnesium 0 because that is the species that was actually oxidized, not the magnesium over here. Reduced, oxygen went from 0 to -2. So I'm going to write everything that I circled, basically, O2, 0. All right, on the next one, we have nitrogen. Actually, can you guys push pause and try to do number 2 and number 4? Number 3, I just want to do together. Okay, so nitrogen went from 0 to -3. So its charge went down. And we're only looking at things on the left-hand side for our answers. So I'm going to write N2. I can put 0 here because that's what it started as. And then H2 had to go up because if you lose electrons, you also have to gain electrons in redox reaction. So I went from 0 to +1. So H2, 0. Oops. Okay. Now skip down to 4. H2, 0 went from 0 to +1. So that means I got oxidized. Oxygen went from 0 to -2. So that's got reduced. Okay, so in number 3, this is a little bit different because it's the opposite. It's backwards. So now I'm looking at Hg plus 2. So Hg plus 2 goes to Hg 0, so that got reduced. So when I report my answer, I write Hg plus 2. because that's the part that got reduced, not just Hg0. That would be wrong. O minus 2 went from -2 to 0, so the charge went up. So I would write O minus 2. So see how that's a little bit different than the other ones we did? Number 5 is going to be similar. So on number 5, give that a shot. You can ignore things that have the same oxidation state on both sides. They're not part of this. Okay, so I'm looking at magnesium 0, and magnesium went from 0 to +2, so I got oxidized. So I'm going to write Mg0, and then Ag plus 1 went to Ag0, so that got reduced. Okay. All right, so now we are ready for balancing half reactions. I kind of like balancing half reactions. I don't know. I like following steps, and this is one that has some easy steps to follow. Okay, so balancing half reactions, redox reactions can be split into 2 halves. You can have a reduction half and an oxidation half. That's how they get the word redox. Reduction, oxidation. Okay, so this is the sample we're working with. We have Zn by itself, so I'm going to write its charge as 0. +1 yields Cu plus Cm plus 2, and that's going to be 0 on that side too. Okay, first thing I'm going to do is decide who gets oxidized and who gets reduced. And then I'm going to rewrite using only those things. So I'm going to look at Zn. Zn goes from Zn0 to Zn plus 2. So that gets oxidized. So for the oxidation half, I'm going to write Zn0, Zn plus 2. And then for the reduction half, Cu goes to Cu. Cu plus 1 goes to Cu0. I'm leaving space on purpose, so you should also. Okay, so we know that in redox reactions, electrons are either gained or lost. So in reduction, electrons are gained. In oxidation, electrons are lost. I'm not even going to worry about that because that tends to confuse people. I'm going to add electrons to the side with the higher charge. Okay, so I'm going to look at this first one, and I have +1 on the left and 0 on the right. So I'm going to add electrons to the left-hand side because its charge is larger. So to get me from +1 to 0, I need to add 1 electron. So this is the format I would write: +1 E minus. On the bottom one, I have zinc 0 and then zinc +2. So this time I'm going to be adding electrons on the side that's larger, which is the right-hand side, and I need to get from +2 to 0. So I'm going to write 2 electrons. Okay, I'm going to switch colors so you can see what I'm doing. So the last part is you need to balance the electrons. So this electron has to equal this electron to maintain charge. So I have 2 and 1, so the least common multiple is 2. So I'm going to multiply this whole thing by 2. Okay, so I'm going to end up with a 2 here, a 2 here, and a 2 here. And then I'm going to add them together. Whoa. Let's try that line again. I'm going to add that together. All right, so now I'm going to rewrite everything on the left-hand side of the arrow. So 2Cu plus 1 plus Zn0. And when your electrons are equal, they cancel out. Yields, and then I'm going to rewrite whatever's left over. So 2Cu0 plus Zn plus 2. So this is a little tricky because, you know, if you look at this equation up here, this looks balanced, right? There's 1 and 1, 1 and 1. But it's not balanced because of charge. So on this side, there's a +1 charge, and on this side, there's a +2 charge. So when I go through these steps, that's how I balance my charges. So now I have 2 times +1, I have +2 on the left, and I have +2 on the right. So that's how I that's basically why I'm doing this whole thing. Okay. All right, so I think there's a few to try on the next page. Okay, yeah, there's 4. So if you need help with maybe one more, I'll do one more. But if you feel like you're good to go, then go ahead and push pause, and then you can come back. Okay, so, all right, so first thing I'm gonna do here is decide who gets reduced and who gets oxidized. So the ones that are alone are 0. So I have Al plus 3 going to Al 0, so that gets reduced. So to get me from plus 3 to 0, I need 3 electrons, and I add it to the side with the larger charge. For oxidation, I have Fe0 yields Fe2 plus, and I'm going to add electrons to this side because that's the side with the bigger charge, so plus 2E minus. Okay, so before I can add them together, I need to balance my electrons. So I have a 3 and a 2. So when I'm 3 and a 2, the goal is 6. So I'm going to multiply the top one times 2 and the bottom one times 3. So I have 2. This changes to 6, 2. This one is going to be 3, 3, 6. Okay? And then before I add them together, I can cancel out my electrons because they're equal. And I have 2Al plus 3 Fe0 yields 2Al0 plus 3 Fe2 plus. Okay. So number 2, CO gets reduced. So I go from plus 3 to 0. So I'm going to say plus 3E minus. All right, and then Sn goes from 0 to plus 4. My lines are a little bit crazy tonight. Okay, so I have a 3 and a 4. 3 and a 4, I can make 12. So let's do times 4 times 3. So this would be 4, 12, 4, 3, 3, 12. Okay, cancel out the 12 because they're the same on both sides. Rewrite what is left over. Okay. All right, number 3. Reduction. So it looks like Cu gets reduced. And I'm going to add 2 electrons to the left because that's the side with the larger charge. Sn gets oxidized. And I'm going to do 4E minus because it's 0 and 4. Okay, so now let's think about what is our least common multiple between 2 and a 4. So it's 4. So I'm going to multiply the top one by 2. But let's say you said it was 8. So you'd multiply this by 4 and this by 2. Your coefficients would all come out to be an even number that you could reduce down. So keep that in mind. I think it's going to be pretty simple to find the one least common multiple when we're doing these. Okay, so cancel out the 4 because they're the same. So 2Cu plus 2, Sn0 yields 2Cu0 plus Sn plus 4. All right, and then the last one, who gets reduced? Fe. So Fe plus 2 plus 2E minus yields Fe0. Al gets oxidized, so Al yields Al plus 3 plus 3E minus, and then anytime you have 2 and a 3. You try to make 6, so I'm going to multiply the top one times 3. So 3, 6, 3. Bottom one by a 2, 2, 2, 6. And then we can cancel out the 6. And then I'm done with 3 Fe2 plus 2 Al yields 3 Fe0 plus 2 Al3 plus. Okay, good. We made it through the whole thing. Okay, so that's that. And then tomorrow we'll wrap this up and start voltaic cells. I will talk to you later. Bye.